Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on the jet propulsion of ships when the inlet orifices face the direction of motion of the ship. So in our last lecture, we have discussed the theory part of this jet propulsion of ships when inlet orifices face the direction of motion of the ship. That means at which direction the ship is present, like the ship is moving in the same direction the inlet orifice is present. Actually, just I'll remind this diagram how it was. Like suppose this is the ship is there, and in the sea, this is the end part of this, and this is the starting part of this, and here this is suppose that line through which the water is moving, and here suppose here actually the centrifugal pump is present here, and the ship is moving in this direction, and the jet of water which is coming out from this centrifugal pump here. So the velocity of water is coming out at this direction. So here orifice is present at this point. The orifice is present at this point, and the water is coming at this in this direction. Okay, the water is coming from here at this direction. So the same thing is given, like when the inlet orifice face the direction of motion. That means this is the direction of motion. So inlet of inlet of the orifice also present at this same point, at this point. Okay, so through this the water is coming inside, and this is the pump part is there, and this is the inlet, like you can say suction pipe or suction inlet of this pump, and this is the delivery pipe or outlet of the pump, you can say. Okay, so this is the velocity of jet which is coming out, and at this direction the ship is moving. So here I have taken the question, the water in a jet propelled boat is drawn through inlet openings facing the direction of motion of the ship. The boat is moving in sea water with a speed of 30 km per hour. So here we can draw some sea water. Okay, so this one we can give, this is the ship, and this one we can write this sea water. The absolute velocity of the jet of water discharged at the back of this is 20 meter per second. So as I told you, this is the jet of water which is coming out. So this is given 20 meter per second, and the area of the jet is of water is given 0.03 meter square. So area of the jet is given. Find the propelling force and efficiency of the propulsor. So two things we need to identify. This question is very simple. It is given. So let's find out the solution. We can write what are the data given here. By seeing the question, you can find out initially the boat is moving in a sea water with a speed of 30 km per hour. So this u is nothing but it's given 30 km per hour. This is the movement of the ship, we can say. So first one we can write, this is speed of boat, which is denoted with an India like letter is u, and that is given 30 km per hour, and this need to be converted into meter per second. So meter per 1 kilometer equal to, we can write 1000 meter here. So let multiply 1000, and this 1 hour we can convert into second. That is 1 hour 60 minute. Again 60 minute, we can write 60 second. So this can be cancelled. This is going to be cancelled here, and this is 5. Okay, this is 50 by 6. 50 by 6 we can write, this is 8.3. 8.33 we can write this much meter per second. This is u. Similarly, here it is given speed of the boat, given speed of the now absolute jet velocity. So we can write velocity of jet, but here it is given absolute velocity, so we can write this is absolute velocity of jet. This is nothing but v. So this is given 20 meter per second. 20 meter per second, and area of the jet also given. So let's write down area of jet. Area of jet, which we can indicate a small a. So this is given 0.03 meter square, and we need to find out the propelling force and efficiency of the propulsion. So this is the question is given very simple, so you can easily find out the force. Yeah, let's write down the propelling force. The propelling force, which is nothing but, we know that the formula F equal to, we can write this is rho A V plus U into V. This is the formula what we got in our last derivation lecture. So here rho is nothing but density of the fluid. Okay, so density of the fluid, if it is not given, seawater somehow different than the normal water. If it is not given, you can consider the direct density of the water. How much it can consider? It is 1000. Area is given. This is already given 0.03, and this is V plus U. So this is 20 plus 8.33 into this is 20. So from here we can find out what is the force. It is direct formula actually. Based on this formula, if you know the formula, we can easily identify. If you don't know also, you can derive from this diagram. So force equal to, you can write, okay, let's solve this. This is 1000, right, 0.03, and here again multiply this 20, again multiply this 28.3, 28.33, 16,998. So we can write 16,998 Newton. Okay, this is the propelling force. And the next one is, we need to find out the efficiency. So efficiency also formula is there for this. The efficiency also we have derived in our last lecture. We can see, we can give the notation eta. This formula actually 2U into V plus 2U, V plus 2U. So here you can see 2U by V plus 2U. So you can write like 2 into 8.33 divided by, this is 20 plus 2 into 8.33. So you can just solve this one. Yeah, 2 into 8.33, 16.66 will come. Yeah, so I'll write this is 16.66, and here we can get 36.66. So I'll just divide this, divide 36.66, 0.45444. So here we can write 0.45. Efficiency equal to, you got 0.4544, or we can write this is efficiency equal to 45.44%. Okay, so this is the efficiency of the propulsion, and this is the propelling force of the propulsion. So this is the very simple question I have taken to calculate the force and the efficiency of the jet propulsion of ships when the inlet orifices face in the direction of motion of the ship. And I hope you understand this problem. It is not that much difficult, very simple only. Direct formula you can use, and you can find out the answer for this. If you're having any kind of doubt and query regarding this, you can give a comment in the comment box. Thank you all.